Hello, everybody. So this video is going to be to go over Lab 14B, which is right here. So in Lab 14B, this is the second lecture that we're going to be working on the Tetris game. And so essentially, if you did the lab from last week, the Lab 13B, I believe it was, then what you learned was how to get some Tetris pieces drawing on the screen. But the Tetris pieces that we had drawing on the screen were just kind of spinning around. They weren't really doing anything. And so what we're going to be doing in this lab is, as it says here, we're going to be creating this class called the game area class. And the game area class is going to be basically manage our pieces for us. Now, we can do this piece by piece, and there's quite a few pieces to do. A lot of it we're just going to copy paste, but when we copy paste it, we can talk about what's going on there. And so let's go ahead and get started. So looking at the instructions, it says we'll go over how a 2D array maps to a game board in the lecture. Okay, well, guess we're doing that now. Project setup, open your existing Java project in Eclipse where you have your completed piece and main. I'm not going to do that. I'm going to create them new right now. And it says, or download the updated ones provided in Canvas LMS. That's here. So if we scroll down, we'll find them. Okay. So let's go ahead and do that first. So looking here, we're going to have a main.java. We're going to have a piece.java, and we're going to have a game area.java. So we're going to have these three files in our project. And let's go ahead and get started. So let's open Eclipse, which I have here. I'm going to create a new project for this. So I'm going to go to new Java project, and I am going to select, I'll just call it Lab 14B. Maybe I'll call it Tetris V2 or something like that, since this is the second week we're working on it. And then I'll go ahead and hit finish. So I've got Lab 14B here. I'll expand that, go down to SRC. And now I know I need those classes. So I'm going to do new class three times in the same project. So the first time I'm just going to call it main with a capital M, and then just hit finish. And then I'm going to go back here and do it again. New class, and I'll call that piece, which is a Tetris piece. And I'm going to hit finish. So notice that we have main.java and piece.java now in the same project. And then I'm going to do this a third time. Click on SRC, right click, new class. And we're going to do, I think we called it game area, capital G on game, capital A on area. And I will hit finish. So I've got all three of these files open here, main.java, piece.java, gamearea.java. They don't have any code in them right now. And in fact, we're going to copy main.java over here. We're not going to need to keep anything in here, so I'll just delete it all. And I'll go back to the page, scroll to the bottom, and well, I guess actually not the bottom, scroll a little bit, and it'll sample code for main.java and piece.java. And so I'll copy this code for main.java. Be a little bit hard to copy, have to worry about how fast this scrolls. We only want this much. So I will Control C, copy that, Alt Tab back over here. I deleted everything that was in main.java, so I can paste this, and I will save it. So Control C, sorry, Control S. Now this is going to have errors on it, but those errors are because we haven't written the rest of the code yet. Then below this, we have piece.java. So just like main.java, I'm going to copy this. Oop, ah. Okay, there we go. Control C, piece.java. Going to delete what's there so we don't get repeats of any lines, and then Control V, and then Control S, save it. All right, so this is where we're supposed to be starting. Now, this will not run if I try to run this, I'll click the run button. What's happening is an earlier project is running, not the current project. Actually, from looking at this project, it looks like this is going to be the lab for this week. Looks like I have lab 15 in here. I'm using a computer I don't normally use, but it looks like the last time I used it for a class was lab 15. So the next one from here. Anyway, this is not having anything to do with Tetris. And that's what happens when you try to run the current project when the current project run. Okay, so with that said, we've got main.java, which errors. We have piece.java, and then we have game area.java, which is pretty empty. So just one comment on piece.java. So this piece.java is pretty much exactly where we left it last week at the end, except for a couple things at the very bottom. And so at the very bottom, it says add these to the bottom of piece.java. What you've got is a simple method called get current shape that returns the shape of the current piece. And then we have get color, which will return the color of the current piece. And then we also have get random piece. And what this is for is to get us a random piece, because when you're making new pieces in Tetris, right, one piece falls. When the piece hits the ground, you have to make another piece, right? And so we want the piece to be random. And so this will do that. And so you can see what it did was it created, this is an array of piece types, which scrolling up here, piece types are all the piece names, Orange Ricky, Blue Ricky, Cleveland Z, Rhode Island Z, etc. So we're making an array, and we're going to put piece type dot values in there. Well, all of these are possible piece types, right? So basically, if you take all of these things, all 7 pieces, and you put them in an array, then you'll have like the first entry is Orange Ricky, the second entry is Blue Ricky, etc. And so this is going to make an array with the piece names in it. And then we're going to, it says int random index, and we're going to do a random number. And we're going to multiply that random number by the length of the array, which is 7. And that will get us a random number between 0 and 7, but they'll be decimal numbers. So this int out front is typecasting it to an integer. So we're going to get a random number between 0 and 7. Like, let's say, for example, like you generate like, 5 point that, right? So you generate a number like that randomly. And then when you do int in front of it, it'll just cut it off and be 5. And so this is just getting a random number between 0 and 7, essentially, or 0 and 6, I guess. And then we are going to return a new piece of that type. So that's how we're generating random pieces. So that's been added since last time, since we didn't have a reason to generate random pieces before, but now we do. Okay, let's get started on what we're supposed to be doing this time. So we'll have to write quite a bit of code before this will run. I'll go ahead and delete everything in game area too, because if we scroll back up to the top of this lab, it tells us how to start. So it says the game area class, the class will hold a 20 by 10 grid. Okay, so why? Because if we Google Tetris and we look at images and we find hopefully a regular image of Tetris, here's one, and we kind of count here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 wide. And if we see how tall it is, I never actually verified how tall it was, but it looked like 20-ish to me. So let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, so it's 20 by 10. 20 tall, 10 wide. Where are we going? Oh, right back here. Okay, so we're going to have an array that's 20 by 10, and that's going to be our game area. Okay, and then once a falling Tetris piece hits the bottom, we're going to copy that into the grid permanently. So the idea is this, it's going to be, I don't know how easy it will be to explain. Maybe we'll have to open Notepad to show you. Um, okay, that's weird. That's just a file that has nothing to do with this. So like, let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 2, 3, 4. 4 rows, 8 rows, 12 rows, 16 rows, 20 rows. Okay. So like, let's imagine that this is the Tetris gameplay area. Okay. So what's actually going to happen here is that it's not going to be an array of integers. It's actually going to be an array of colors. And so you can see that because if you look here, it says, what are we going to have? We're going to have private final, so that means a constant, int rows, so number of rows 20, private final int columns, so 10 columns, private final int block size 40, so we're every block is 40 pixels wide, and then it says private color and array, so it's a two-dimensional array, and we're going to call it grid. So the grid is going to be set up in this fashion, but what it holds are not numbers, it holds colors. And so the idea is this. So if you have, I don't know how I can draw it over here, but like let's say you have a piece that's like this, right? And it's like, let's say it's red, 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 and then red, right? So like that's a, an imaginary Tetris piece. And so let's say that Tetris piece falls all the way down and it hits the ground somewhere in here, right? Then what we're going to do is we have the Tetris piece and like let's say it hits right here at this location. We can see that, I don't know. If it hits right here at the bottom and it's red, then what we're going to do is this. We're going to change the colors like this. And so we'll change the colors of the background to red, 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 and then we can go ahead and delete the Tetris piece. And down here, this isn't a real Tetris piece. It's just the colors are going to stick around. So like the Tetris piece falls until it hits the bottom. And when it hits, we copy the colors of the Tetris piece into the background, and then they just stay there. Um, and that's how we're going to kind of form this sort of thing, right? So like imagine this Tetris piece here. It falls all the way to the bottom and it's going to hit right here. And when it hits, we're going to change this to light blue, light blue, light blue, light blue. And then we can remove this Tetris piece and we can replace it with the next piece. But the colors will stay behind. And that's the idea. Okay. So with that said, let's go back to the web browser. Here we go. This is what we're starting with. So we'll go ahead and we'll copy this into our project. Notice, remember I deleted everything from game area there. Okay, so there we go. So we have some variables to get started. We also have color and graphics because we're gonna need to draw the gameplay area. Then every class that you can, make a copy of needs a constructor. So the constructor, whoa, not what I need. Trying to copy this. There we go. So the constructor just sets up that array. So when you create a new game area, it will just basically initialize this array for the background. All right, that's all it needs to do. Then we need to think about how collisions work. And so this is a little bit complicated. Um, so basically, what we're going to do, I'll explain it in kind of words, and then maybe we can look at the code. Let's go back here. So I want a different screenshot to look at. Give me a picture where Tetris, this is fine. Okay, so like imagine that this is what's happening in the Tetris game right now. So um, this piece right here, right? If it falls one block, it's not going to hit anything, right? So if it falls one block more, it'll just be this like right here will be down one block right here. And the T part will be one block lower and it still won't be hitting. But if it falls one more below that, it'd fit in this hole, right? Horizontally across here and then down here. And that's where it would finish up, right? So when it hits the bottom, we want to know that it hit the bottom and that it can't go any further. And so the way we're going to do that is to see if the piece can fall. What we're going to do is we are going to, and I'm going to go back to the code. What we're going to do is this. So the piece is piece P, and it says if moving the piece by dx dy. So dx is how much we're moving the piece horizontally, and dy is how much we're going to move the piece vertically. So like if we're moving it down, if you want to move the piece down, for example, then what you would call would be, this is not where to do it, but you would say check collision for piece P. And if we wanted to move it down, that would be 0 in the X direction and 1 in the Y direction. And if you wanted to move it left, for example, that would be -1 in the X direction and 0 in the Y direction. And if you wanted to move it to the right, that would be 0, sorry, it'd be 1 in the X direction, 0 in the Y direction. So this would be right, and this would be left, and this would be down. And there's no up because the Tetris pieces never move up, right? So these would be the possibilities for what direction you can move your Tetris piece in, okay? And what we're going to do is we're going to take that dx or that dy. So like the dy would be, um, you know, trying to move it down, for example. So let's just imagine we're moving the piece down. So if we're moving the piece down, then dy would be 1. So what you're going to do is you're going to get the current x and y position. Then you add where you want to move to. Maybe I will kind of, where's Notepad? Um, so I did. So what we do is we call check collision, let's say for the piece, and we want to move down, okay? So the dy is 1 because we're moving down, okay? So what we do is number 1, get the pieces x and y. X, y location, okay? After we get the current XY location, we're going to add what we want to move to it. So we're going to calculate the new position, right? So basically, in this case, we would just add 1 to the Y position, for example. So if we were moving down, we would add 1 to the Y position, and that's the new position, okay? But now we've got the new position of the piece. But you might not be able to move the piece because there might be something in the way, right? So right here, the piece can move down. But if the piece was like right here, like the blue piece can't move down because there's, something in the way. So after we um, calculate the new position, what we're going to do is check if there is something in the way of the new position. Okay. And if there is, you can't move, right? Okay. If there is, then you can't move. That's really the idea. So if we go back to the web browser, um, so we're calculating the new X and Y position, as I said, and then we have a loop, for loop. So we're going to loop from 0 to 4, actually technically 0 to 3, and 0 to 3 again for the rows and columns. Why 0 to 3, 0 to 3? Because if you remember how the pieces look, let's go back to piece from last time. The pieces are like this. They're stored in a 4 by 4 array. So like this is an L shape in there, right? So we have to loop through this entire 4 by 4 array to do anything with the piece. So we're looping through the 4 by 4 array, and then it says if this block of the piece is a solid, right? Like where the ones are, that's where the piece actually is. So if the block of the piece is a solid, um, then we're going to figure out where that piece is on the board, because the board, remember, is this kind of big 20 by 10 array. So if there's a 1 in the piece array, the 4 by 4, we're going to figure out where that is on the grid. And then if that piece is to the left of 0, right, that means you moved it off the screen to the left. Or if it's to the right of the columns, that means you moved it off to the right of the screen. Or if it's below the number of rows, then that means you moved it off the board, right? So what happens is like the piece can't move over here because this is to the right of the grid. And it can't move over here because this is to the left of the grid. And it can't move down here because that's below the grid. So that's what this first if statement checks. If the position is left of 0, right of columns, or below the number of rows, then it returns true. True means we hit something. Okay. But you also need to make sure that there's not already a piece there. And so that's where you have to remember what I said about like when a piece hits, like you fill in the colors into the background, right? And so if you're to the left of the grid, that's bad because you can't move there. And if you're to the right of the grid, that's bad because that's off the grid to the right. And if you're below the board, then that means you fell too far, so you can't do that. But also, if you try to move the box into a place where there's already a color, you can't because the color are the pieces that have already fallen. So, like for example, right here, this yellow piece, when it falls one spot, it'll be here, another spot, it'll be here. And if you tried to fall one more spot, then the yellow would be here. But the yellow can't go here because that's already red. So what's happening in the code is that we're going to check if the grid, board Y, board X, that's where we're trying to move the piece on the board, on the grid. Um, if that piece is not null. So remember when I said that 20 by 10 array was colors, right? So if there's a color in there, the color will be in there. But until you put a color, it'll be null. So null is empty. So if the grid is not empty, then return true. Return true means we collided with something. And so if you try to move off the screen, that you can't because you collided with something. If you tried to move where there's already a color, you can't because you collided with something. And if you don't collide with anything, then we return false. And so this is below the collision check. So if you hit anything, you return true. If you don't hit anything, you'll end up here and you'll return false. Now, having said that, we're just going to copy paste this. So let's just copy that code, Control C. And where would that go? That's going to go into our game area class. I'm trying to find Eclipse. There it is. And game area. And I have some stuff I just wrote there. Delete it. And this is where it would go. Notice that I have to put it here. I don't want it below the last curly brace, right? Because that curly brace closes the entire class. So I want it right here. So I'll paste it. And there's our collision check. What's next after collision? Okay. When a piece hits the floor or another block, it stops falling. Instead of keeping a massive list of dead pieces, we simply extract the color from the active piece and paint them into the background, into the grid. Okay. Now it says add the following method. So let's see what we're doing. So in order to lock the piece to the grid, so that means you hit something and we're done. What you do is we're going to get current shape. Remember we said we added that to the piece. So we can get the shape of the piece, and then we get the color of the piece, and then we get the location of the piece. So now we know what the shape is, what the color is, and we know where it is. And then we loop through the 4x4 matrix for that piece. So, 0 to 3 again, 0 to 3 again. And if the shape row column is a 1, again, remember how the pieces work. So the pieces are all like this. So there's like where there's a 1, that's where the actual piece is. So where the actual piece is, then we're going to go to the correct location. It says only locks blocks that are visibly on the board. So what we're going to do is we're going to go to the grid, and we're going to go to its Y location and its X location, and we're going to put in the color. And that will copy the piece into the background. And that's how we will keep it there for the future. So let's go to the game area. Let's go below this function. So again, notice the last curly brace is down here somewhere, but I'll paste this here, save. Then we have to draw the game area. Now the drawing the game area is not that bad. So the game area, it's, a certain number of rows, 20 rows, 10 columns. So we're going to loop through every row and every column. And it says, if there is a color saved here, draw it. And so if the grid row column is not null, null means there's nothing there. So if it's not null, then there is something there. Then we're going to set the color to whatever that color is supposed to be. And then we're going to draw a little rectangle there. And if you look at this where it says like fill rect call, and it says like column times block size plus 3, row times block size plus 3, block size minus 6, block size minus 6. That's the same. This right here is the same exact thing we had for drawing the pieces. And what the plus 3 and the minus 6 is here is to kind of leave a little bit of black space between the blocks. Okay, so let's put our drawing function in. I'll copy the whole thing here. Control C, go under there, save that. Now, when I did that, now we're down to the sample code for main.java and piece.java. And when I saved that last bit, I don't know if you can see here, but there's a little yellow icon there and yellow icon there. Those are warnings, not errors. So I believe we have enough code for this to run again. So I'm going to go to main. I'm going to hit run, and we'll see what happens here. Remember to save all 3 of your files, though, and then we can run. Okay, there it is. We'll take a look at the main in a minute. So you can see that the piece is falling. And actually, I can move it left and right slowly. It's not really working very well. And I think A and D are rotate. Yeah, so like I have A and D here. See, I can spin the piece. Oh, I also can press down. And so this is starting to look like Tetris. It doesn't move perfectly yet, but it's starting to look like Tetris. And you see, like once the piece is there, then another piece is generated. So we'll look at the code for main to see how this happens. Also, I'll put in a few more things. I'm trying to get a whole, oh, well, there is a whole row. I can't really pause this, so I will put one more piece in and then stop. All right, so down here, you see how there's a couple rows. those rows have been completed, but they don't disappear like they're supposed to for Tetris. Also, I think there's well, I can't show it with here, but there's another problem with rotating. If I take this over to the edge and I rotate it, oh, I guess it didn't happen. There we go. If you try to rotate a piece and it ends up off the screen, like happened right here, then you can see we got an error. So that should be fixed too. But this is enough for this week. Let's take a look at the main now. So the main is got our game code in it. So width and height of the window is 10 by 20 currently. And we have 40 by 40 pieces. So I'm multiplying, 10 blocks high. Each block is 40 pixels. Or sorry, 10 blocks wide and 20 blocks high. And then we multiply by 40 to get how many pixels. There's some constants related to the Tetris game that are here now, and says variables for Tetris. So we're timing things out with counters, and so currently um, there's a counter for falling, and then there's a speed for falling. And so when it says fall speed equals 30, what that means is one block falling every 30 frames. That's what the 30 means. And the fast drop speed is going to be one block every 2 frames. So when it's falling fast, it can fall very fast. And when it's falling slow, it's twice a second, basically, right? So this is twice a second, half a second between things. But if I press down, right, they zoom. Also, the game doesn't end when the pieces get up here. But so every 30 frames, it'll drop the piece on its own. Or if you're pressing down every 2 frames, it'll drop the piece. Then we have constants related to movement, which is left and right movement. So right now it says move speed equals 8. So that's every 8 frames, we can move left or right by 1. Now, this is not optimal. It feels sluggish. If I press, like, it's really it doesn't move very nicely left and right. But that's what we have now, and it's every 8 frames. So, like, if I change this to 2 or 3, 2, and I save it, see, now I can go really fast left and right. And if I change that to, let's say, 15, now I can't move fast left and right. I move pretty slow. So you can control the speed of the game through these constants. So like I could put that at like 6, for example, and then I can move pretty good left and right, and I can press down to drop it. Can rotate the piece. Like this actually feels okay. Um, so that's working okay. So once I have these constants set up, then what are we going to do? Well, I'm going to generate a random piece to be the current piece. So that's again why we wrote that method called get random piece. So make a random piece for the current piece and get a random piece for the next piece. So the next piece is already ready to go. There's an enum here, an enumerated thing. So these are what possible directions you might be pressing. So you can press left, right, down, or none. And then the current move direction, which is a variable, is currently none. Now, the reason I'm doing this for movement is because um, we're only moving every so often, right? Like if move speed is 6, I guess it was supposed to be 8. But if the move speed is 8, that means the block moves only once every 8 frames. Um, but we want to get input every frame, right? Every single frame, you're pressing a key on the keyboard potentially. And we don't want to look at the keyboard once every 8 frames. We want to look at the keyboard every frame. And so what we're going to do is every time we go through our game loop per frame, we're going to check what direction you're pressing. And if you're pressing left or right or down, we're going to keep track of that. And that's what this move direction variable is for. Then there's this, which is left over from a much earlier lab, where we are just getting a list of all the keys currently being pressed. Now we have our game area. The game area is what we just wrote. This sets up the window to draw. This gets our keys. Now, if you look here, um, in this section, this is where we're like reading the keyboard to see what keys you're pressing. And down here where it says key released, um, A and D are here. VKA is the A key and VKD is the D key. And they're mapped to rotate left and rotate right for our piece. And so since they're here, you can actually, if you hit the key really fast, you can actually rotate really fast. And the reason it's here is because I know that you can only move left and right and up and down at a certain speed. But I read on the internet that um, for rotating, as soon as you press it, it happens like it happens. So that's why rotating is currently on the A and D keys, and it's fast. Okay, so every frame it does this. Then we set the timer. The timer's every 60 seconds. Sorry, every 1/60th of a second to get basically 60 hertz. It's not 60 hertz because it's an integer, so it's like I think we're actually like 61 frames per second or something. Um, then we have our game loop. And what does that do? We update the position and then we redraw the screen. But how do we update the position? Well, let's look. If pressed keys contains left, we're going to set the move direction to left. Seems reasonable. Or else if the pressed keys contain right, we're going to set the move direction to right. Otherwise, we set the move direction to none. I was originally thinking that we would have left, right, and down in here, but it didn't end up in here. The down didn't. Um, Now, after we do that, we're going to handle left and right movement. So the whole point of having that counter, remember where that counter where we said move counter 0 and then move speed 8, is the counter is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. And when it hits 8, so when move counter 8 is greater than or equal to the move speed, which is 8, then we're going to set the move counter back to 0. So this much of the code here, it makes the counter do this. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then after that, it goes back to 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. Back to 0. 1, 2, 3, 4, 5, 6, 7, 8. Back to 0, and so on. So this code right here just goes 0 through 8, back to 0, 0 through 8, back to 0. And then um, only when it resets, so it has to count to 8 before it goes back to 0, right? So when it counts up to 8, only then does it actually move the current piece. So it has to count to 8 before you can move a piece. And that's why when we run this, um, oh, I have this here. This is not going to run with all those numbers typed. Ah, there. Um, so it has to count to 8 before the piece moves, and that's why the piece moves kind of slow, right? Left and right is kind of slow because you can only move left and right once every 8 frames. And that's what that does. Okay. Now, before it moves it though, it does current piece move left. Sorry, it checks collision first. So before you move a piece anywhere, you have to check if it's going to hit something. If I were to take this out like this, so I got rid of the if statement, but you can still move left, then when I try to run this, if I try to move left, look what happens when it gets to the edge of the screen, right? Error. It ran off the screen and we got an error. And that's what the check collision method is for, is to check if it's going to go off the screen and stop it from going off to the screen. So if I hold left here, you see it goes to the edge of the screen and it can't go any farther. If I go to the right, it can't go off the screen to the right. And if you go up to the bottom, it can't go off the bottom either. So you have to check if it's going to hit something first. And if it's not going to hit something, then we can move it. So the check collision function checks if it's going to hit something, and you do that before you actually move the piece. All right. Now, these two lines here, what they do is they check if you're pressing down. If you're pressing down, we're supposed to be moving fast. Otherwise, you're moving slow. I say moving, I should say falling. So if you're pressing down, you're supposed to fall fast. If you're not pressing down, you're supposed to fall slow. So like this is falling slow. If I press down, fast, right? Fast, slow, fast, slow. So this checks if we're moving fast or slow. And basically there were two constants for that. So fall speed normal is 30 and fall speed fast is 20. So this means falling once every 2 frames. I said 20, but 2. Um, if you're falling fast, you're falling once every 2 frames. If you're falling slow, you're falling once every 30 frames. So in here, we figure out whether we should be falling at 2 frames or every 30 frames. And then we basically do the same thing as the movement function, where the counter goes over the threshold. The threshold is either 2 or 30. And if you count up to the threshold, then we set the counter back to 0 and we drop the piece down. Although we only drop the piece down if it's safe. So, um, so if it's empty below the piece, then we move the piece down. Otherwise, if there's something below it, then we lock the piece. So game area lock piece to grid, that's what copies it to the background. And when you copy the piece to the background, you need to, the next piece becomes the current piece, and the next piece we're going to generate a new one. And then we add one to the counters, and then that's it. That's basically our game so far. All that's left is to draw it. So in order to draw the game, we just run gameArea.draw, which draws the background. Current piece.draw draws the current piece. And then there's a note. The next piece could be drawn, but in Tetris, I believe there's usually a place to see the next piece. Like, see if we can find a real screenshot here. Yeah, so like here's the original Tetris on Nintendo. So, um, right, the current piece is over here in the game, but the next piece that you're going to get is shown off to the side. And so currently we don't have any space. This has been running for who knows how long. We don't currently have a space off to the side of the game to display the next piece, but we could add that later. So we're not displaying the next piece right now, but we could. Like I could add it right here like this, but it'll just be sitting up there. So this is the next piece. So you see now the green one or the yellow one comes down. The next one to fall is going to be that green one. There it comes. Um, anyway, you get the idea, right? So if the game area was bigger here, like if we have some space off to the side, we could be displaying this next piece over off to the side rather than, in the middle of the gameplay area. So well, we can just comment that back out. And that's it. That's our game so far. So, um, you can turn in whatever you want for this, really, because I mean, the code was all written for you. It does say down here what to turn in, scrolling all the way down. So you should turn in your completed game area.java file if you can. Um, and, if you get it running, show a screenshot. And that's due April 24th, which is, I believe, Friday. So, yeah. I'm gonna scroll through the game area once more, just to in case anybody is kind of needs to see the whole thing. So be careful with all your curly braces. One thing I will say is that, well, let me just scroll. So we're at line 49 to 80, and scroll. Oh, that's the end. Okay, so we have like 80 lines or so. So top to 30, 32 to 60, 61 to 84. So like if I like accidentally delete a couple of these, or like maybe I add a couple extras or something like that, then obviously that's going to make the code not run. The reason I'm doing this is I'm going to just copy all this. And if that happens, this is a good use for AI. I don't use this computer, so hopefully I can um, access this here. I'm not logged in or anything. So let's say fix this Java code. And by the way, if you're pasting something into AI and you want to go to the next line, if you press Shift Enter, it'll go to the next line without sending it to the AI. So Shift Enter. Anyway, and I'm going to put Control V and pasting everything. And I've made some errors, right? So it finds the error pretty quick. The issue is just broken braces and structure, blah, blah, blah. And so AI is really good at fixing these kinds of errors. So if you have issues, try that. Just copied it. I'm gonna come back here, delete everything, paste it, save, and see we're back to running again. So, all right. I think that's gonna be it for this. This is like a 45-minute video, I think, or 50-minute video. So I think that's too much. So let's go ahead and get this stopped, and hopefully this is useful to somebody.